I decided to draw a couple of example dot diagrams so that we could use them to show you how to complete the sheet that I asked you to do this weekend. So we're going to start by drawing XEF2. Remember, the steps that are laid out on a previous video on the homework page, dated for Thanksgiving weekend. So XEF2 has a total number of 8 plus 7 times 2 is 14 plus 8 is 22 valence electrons. So I'll write it right there. This is for XEF2. The second step, as laid out in that video and also in class, is that you draw a skeleton structure and put the element that's closest to the middle of the periodic table in the center of the skeleton structure. There are three guidelines I gave you for those. One is one's closest to the middle of the table, another one's what's less electronegative, another one is what has the most bonding sites. And this one, in this case, the bonding site rule doesn't get obeyed because fluorine has 1 and xenon has 0. But xenon is less electronegative, number 1, so that's why it goes in the middle. Number 2, you need to follow, as much as possible, symmetry, and so this is more symmetrical. Number 3, fluorine is the very, very, very most electronegative element on the table, so it can never be put in the middle because things in the middle tend to be giving electrons away and fluorine only takes. So of those 22 valence electrons, now I have 4 in the picture. So I take away 4, that gives me 18 electrons to distribute. So if I put them in like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I still had to have 2 more, and everything has 8 around it. So in this case, this is that rule 7 I gave you in class on Thursday that says you had to put the extra ones around the middle. So that's our dot diagram for xenon difluoride. Now, if we take a look at our chart, we're supposed to trying to get rid of this. There we go. Take a look at our chart. We're supposed to fill out this table. Xenon difluoride was number 14, so let's just go down to number 14 so you can see where it goes. Doesn't really make a lot of difference. And by the way, I noticed you'll need to extend this as you go on. We're supposed to go up to 20 this weekend. So XEF2 would be here. You won't be able to subscript on this. You drew the picture on the paper. The total electron domains this is around the center atom. If you remember from my picture, the number of electron domains were 5. 1, 2, 3. A domain is any kind of bond, whether it be single, double, or triple, or an unshared pair of electrons. So 1, 2, 3, 4, 5. So 5 domains, and of those domains, while I have this screen up, of those domains, 2 of them are shared and 3 of them are unshared. Unshared means there's no other atom connected. So 2 shared domains and 3 unshared domains. So we would go to our total domains is 5. And I'm going to go ahead and do the unshared because I just talked about that. So the bonding domains is shared, that was 2. And the unshared was 3. Now on the website, if you go over here and we click on our homework page, my computer at home is kind of slow. We have this little geometry chart, and it tells us on the geometry chart that 5 domains is called trigonal bipyramidal or trigonal bipyramidal, assuming this chart comes up eventually on my home computer. There we go. So we have 5 domains, trigonal bipyramidal or trigonal bipyramidal. Of those domains, we saw that we had 2 shared pairs right here and 3 unshared pairs. So 2 shared, those are called shared pairs, bonding pairs, and unshared pairs are non-bonding pairs. So 2 shared, 3 unshared, so that means our actual geometry is going to be linear. So you're going to draw that in a straight line. So you come over here to the electron domain geometry. You would type in trigonal bipyramidal, and the molecular geometry is linear. And that's as far as you need to go for this weekend, just over to column H. So let's do the other one that I had on my list, and it was BEF2. So I picked this one because there's a little typo on the template. So BEF2 is going to have, well, I'll show you what that is in a second. So BEF2, you got beryllium has 2 valence electrons and fluorine has 7. So 7 times 2 is 14, and then 2 more makes 16. So we have 16 valence electrons. Beryllium will go in the middle for the rules we talked about earlier, for the reasons we talked about earlier. Take away 4, and the when you take away 4, that gives you 12 to distribute. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The fluorines now have 6. The beryllium does not. And here's the typo. So let's take a look back at the template. Oh, no, it's not on the template. I take it back. It wasn't on the template. It was on the list that we're supposed to do. So if we go to Google Classroom, here, take a look at the molecules and ions to draw. You'll see some typing over here in these columns. So on 18, notice that boron does not follow the octet rule. It will have 3 domains. This one, BEF2, boron does not follow the octet rule, but this should not be boron, that should be beryllium. So there should be an E right here. But the bottom line is it's going to have 2 domains. Beryllium will have 2 domains. It does not follow the octet rule. Also, you remember hydrogen doesn't follow the octet rule. So those are 3 things that do not. All right, so it has 2 domains. Let's go back and look at our picture. We have 2 domains. Now we go back and look at our template. And on our template, it's number 20. It'll look like this. So you would have BEF2 in that column. Total number of domains around the center is 2. The electron domain geometry then has to be linear. 2 domains, linear. Molecular geometry is linear. Electron geometry is linear. You have 2 and 0 for those columns. So electron domain geometry, linear. Number of bonding domains, 2. Number of non-bonding domains, 0. And the molecular geometry has to be linear. All right, so I hope that clarifies a little bit how to complete this sheet. You draw the picture, then you decide the total domains. The total domains determine the electron geometry, and the shared and unshared pairs determine the molecular geometry. And you base your answers on this chart. Shared and unshared determine molecular. The electron geometry is determined by the electron domains. So, I hope this helped clarify, and I'd like to see you push on getting these done.